Hey Shai, how are you doing?
I'm well. How are you?
Oh, even better, I would say. What I heard is it's too cold in your country, right?
By Israeli standards, it's cold. By I guess pretty much every other northern hemisphere country, it's summer. My
Yeah,
Canadian friends walk around in t-shirts all winter long here. So,
yeah. But how cold or warm is it now?
14 degrees Celsius. So
And how warm
I'm
should it be?
freezing.
How warm should it be?
20.
Okay,
Anything below 20 is cold here
okay.
for native.
So you should debug that, right? The reason.
Yeah, it's habit, I guess. So.
Last time we started to talk about debugging, and and what we did, or what I tried to do, is to remember now what features Visual Studio Code has, and you mentioned the IntelliJ, and we talk about method breakpoints, which are basically simplistic. So you just put something on the method and it stops. I would say what you can do with it, right, is check parameters. And if you have other parameters, you see what's going in and what's coming out, hopefully. So this is
The
like,
the main value of a method breakpoint is that you can break when the method exits, because the way method breakpoints work by default is that they have a method enter and method exit events uh, in the integration for the debuggers in the JVM itself, and that is global. And the reason method breakpoints are typically slow in the actual JVM is because it happens for all the methods based on a pattern and not a specific method. So it's really hard for the IDE to pinpoint the specific method and only get the events on that. So it's naturally slow. What the IDE does is it simulates method breakpoints by putting a method enter, making the method enter event essentially a line breakpoint, and the same thing for the method exit. And essentially, it sort of creates a simulation of method breakpoints, and that way it's fast. So if you create a breakpoint in IntelliJ and you expand that to see the method breakpoint, you will see that it's by default it's checked that it's a simulated exception and not the regular method breakpoint. It doesn't actually map to a JVM event for method breakpoints.
so what you are saying
And
is that in
that's kind of an
IntelliJ they are
implemented
setting two
detail.
line breakpoints, one at the beginning and one at the end, to
Yeah,
have both, right?
exactly.
Which is faster.
Exactly. So exactly, that's the reason they do that. There's having a method breakpoint is still very valuable for the exit functionality. So if you want to break exactly on the exit and say your return call has lots of entries, or the method has kind of bulky, or the method has lots of different return entry areas statements in it, then it's really a hassle and sometimes impossible, because you want the return code to occur first and only then hit the actual breakpoint. So having that a method breakpoint is actually more valuable there, because then you can grab stop the execution after the return physically occurred. Now that's still not as useful, because you stop the execution and the method's already finished, so you're already returning. The main value there that I've used it for is in tracepoints, where you can essentially use a method breakpoint, any breakpoint, to print details about the breakpoint where it's hit. Essentially, it's a log, and normally you can't put a log in a method after the method returned. And with a method breakpoint with a return, you can do that. So you can do sort of things like check for race conditions and things like that, like print when the method enters and print something else when the method exits. And you can see the exact point where the method exits. And normally, if you do a system out println and the start and the end, it won't be correct, because first of all, the method might return in the middle. But more importantly, the return statement itself might include a method call inside it or something like that, some additional logic. And you want the second print line to be after that code executed. And only method breakpoints can provide that capability. So that's pretty nice. And and I use that to detect traces and stuff like that.
But wouldn't be a line breakpoint at the very last statement in a method more useful? Because then you would see, the contents of the method as well, right?
Not for that particular case. And in specifically, if you want to check that the last line and don't care about the content of the return statement or what it does there, then yeah, sure, that's great. But if you want to let the method execute completely, then it matters.
What I meant is, the line point at the return statement. This is what I meant. Because then I'm inside the method and I see, the state, what happened before the return statement, right?
When stepping over, the line, when you actually, your next action is to step over, then probably, then a line breakpoint is better. For the case of a trace point where you want to get a printout exactly when the method finished completely and not before that, not in that case, then method breakpoints are pretty much the only way to do that. It's also possible to use method breakpoints at scale. So, for instance, I can put method breakpoints based on a pattern. And so, for instance, if I want to see all the calls to methods that check return Boolean values, I can actually do that. I can place a method breakpoint on all of those cases and do a printout whenever an isX method is invoked and essentially get that. So that isn't as useful, but there are some edge cases. For instance, if we have a polymorphic structure and I can bind a method breakpoint to every one of the methods based on a naming convention of a class. And that way I can sort of print out where each, a sort of debug log, poor man's debug log situation, where I can actually see which methods are invoked in which polymorphic instance of a particular class. And do that based on naming conventions only. So, for instance, if I have a driver sort of situation where I know everyone derives from driver and usually names their class X driver, something like that. So I can use a pattern to place a method breakpoint on every single one of those classes that end with the word driver and print whenever the method initialize is invoked for each one of them. And get a stack trace and everything. I can do all of those things without actually physically breaking. So even if I get lots of output there, it isn't a problem because I can then just review the output at my convenience because it's a printout. It's not. It doesn't stop at the breakpoint.
I think the trace point is called logpoints in Visual Studio Code.
Yeah.
And the annoying thing in
Visual
Visual Studio Code is you have to put them one line later.
Lost you there for a second. Yeah, it is called logpoints in Visual Studio Code.
And the annoying part is that you have to put them one line later to catch it. So, if you put the log point exactly
in the case of, you mean in a return statement, it's not so much
inside a method. So if you do the log points, sometimes there can be expression. But the expression is available one line later, It's not exactly in this line. So if you would extract something, so you have to do it one line later. It's just, you have to know it.
Yeah. Yeah, you need to, the expression needs to be in scope in order for this to work properly. I think the way that Visual Studio Code shows it is a bit confusing. In IntelliJ, it's shown like a regular breakpoint, just with a different color. So you see the correct line where it's at. Visual Studio Code is actually doing it relatively nicely because unlike with IntelliJ, lots of people don't even know the feature exists because it's so well hidden. It's more functional, but it isn't as accessible to developers. And VS Code actually did a really good job at exposing that particular feature and bringing it to the forefront for developers. So it's really easy to notice. But the problem is, a drawback actually is that it's rendered as if it's an additional line of text, and it isn't. It just shifts the context a bit. So it looks a bit confusing that you don't have access to some fields that you supposedly should have access to.
Yeah, it's, what do you have to do? There's a curly brackets which are optional. They can put the statement there, and then you will find in the debug console the output. But it is hard to debug the log point actually, because if you just put something which is not available, I think it will print out just the variable, not the value. It's just the reference, and but also useful. And what's the next thing, which is interesting, of course, are field watch points, right?
Yeah. So with field watch points, and this is something I recently gave a talk, and I assumed more people know it than they did, because very few people raised their hands about. Actually, more people raised their hands saying that they weren't aware of field watch points before. And technically, they're not breakpoints. You put a breakpoint on a field. It's technically a watch point, and the reason it's a watch point is because it breaks in a different location from the breakpoint itself. It breaks on access to a field or on writing to a field. You can pick either or both. And that way you can essentially avoid getters and setters to detect changes to a field. I'm not advocating that, by the way, but
why not?
You can essentially... not in the general situation, like Lombok and everything is fine, and having good properties. I'm saying that we need encapsulation, not don't make fields public. That's the and obviously records are great, but we can get inspect mutation to a field or read from a field, which is a very common thing where you get a sort of race condition where a field suddenly changes right after initialization, and someone A changed it, which you want to know who, or B, you want to know who read the value before it was changed. So with a field watch point, you can actually get all of those details without problem.
Why it's called watch point? Is it not supported by JVM internally? So this is like a polling mechanism which polls the state, or because
that's not the reason. Reason is that it stops in a different location. A breakpoint stops at the breakpoint, so you put a breakpoint and it stops there. A watch point stops in a different location. That means we're looking at the field, and then the physical will step over at a location of the code. So for instance, if a field is defined in line 9 of a class, later on a completely different class will stop at line 200 because that line accessed the field. So you end up with a breakpoint in a different location from the watch point. Essentially, the step over will continue in a different location. And that's why breakpoint doesn't make sense here. It doesn't stop on the field. It stops in the access to it.
So the field watch point is a kind of breakpoint factory or breakpoint builder, right? So it just...
you're sort of watching it.
Notifier, right? So it says, okay, if someone changes me, you will stop. So and it causes a breakpoint at this location which change the state of the watch point.
Yeah.
Nice. We had already a chat about exception breakpoints, and we said it's really hard to catch them because if you activate that, then all kinds of exceptions are going to be visible. So it's less useful, you said, right?
It's less useful unless you have the filter, which I think should be the default for every IDE, where you can define essentially that exceptions that are caught in the Java classes or the Sun classes don't stop the process. And the thing is, lots of times people say, oh, I don't activate all exceptions, that specific feature. But this sort of costs us, because lots of times, and this is something that happens to me a lot, and I'm guessing it happens to lots of other people, is that I run the project, I don't look at the console because I'm doing other things, and there's exceptions logged into the console and I don't notice them. And then I just restart the application. I lose all the exceptions that were logged there. I assume everything was fine. And there were lots of printouts, but I didn't see them. So the thing is that if I stopped at an exception breakpoint, I would have noticed it. The IDE would just jump there and stop me. And that's why I think activating all exceptions is immensely useful, But it doesn't work in the default setting because it will essentially stop every time that you do pretty much anything in Java and or in the JVM.
Because
And the reason
Java throws exception internally. That's the problem, right?
yeah, historically, they stopped doing that in recent versions of the JVM, but lots of the existing code relies on very old APIs, and these old APIs, for instance, number parsing, just through an exception. There was no way to parse the number in Java back then as part of the JDK without throwing an exception if the data was invalid. So if you're doing an HTTP connection, it would throw an exception for a field which might be numeric and isn't or is missing. And you'd end up just having to catch that exception and deal with it. And the JDK does that internally. It catches the exception, and I understand the developers that did that. They didn't really have a choice. And they caught the exception, they handled it, but I don't care about that. I don't want to stop at those exceptions that are handled properly inside the Java or some packages. So there's a feature to filter out such exceptions inside IntelliJ. So you can grab all exceptions, and ignore the exceptions that are caught and handled in the Java and Sun packages. And once you do that, then everything works properly. And you can just run the application. It will only stop in exceptions that actually matter. And that's really useful to have running all the time.
Okay. You maybe wonder why, from where I get the agenda, and this is because I bought your book, and and I'm looking at the breakpoint chapter, and we talk about a lot of that, but you use different names, like for instance the tracepoints. I called it breakpoint last time. And so now we're coming to tracepoints and suspend state. So tracepoints are like log points, so we covered them. And what is suspend state?
So by default, when you have a breakpoint, what it does in IntelliJ is suspend all threads. In Visual Studio Code, by the way, it only suspends the current thread, and as by default. And tracepoints and log points essentially are breakpoints that don't suspend any thread. So you reach the breakpoint and you don't stop the execution.
Okay.
Now, when you don't stop, you can actually do something like print out. In IntelliJ, there are additional options besides printing out, like printing the stack trace and doing all sorts of other things like that over there. But the suspend threads is still a very valuable feature. So, for instance, if you suspend all threads, then you can inspect all the different stack traces and and get some additional information about them. If you only suspend the current thread, then the other threads are running. You can't really touch them. But you can also, as you debug, see all sorts of things still working. Like, for instance, you put something into an event queue that's supposed to occur asynchronously. You can actually see that running as you step over and not wait for it to actually occur. So there's advantages to both approaches, and IntelliJ lets you toggle that to suspend one thread, all threads, or no threads.
Interesting. So if you're in a team and the developers are using different IDEs, they may get different results, right? You have to be careful with it.
Yeah, that's always true with the debugger. When you have multiple threads, you'll always get, without being in a different team, you'd get it yourself when you're running.
No, same team, twice. Different IDEs. But even if you default in IntelliJ, it suspends all threads, and you have Visual Studio Code and it suspends one thread. So it's very likely that you will get different results, or at least different output.
Yeah, the IDEs have very different behaviors, not just there. Things like evaluate expression. People lots of times think that evaluate expression is one of those things that happens in the JVM, but it's really the IDE simulating that. And it does a pretty good job of simulating that, but there's nuances in the implementation there. You won't run into them normally. I know that in Lightrun we had a lot of complexities because we can't simulate to the same level of an IDE, mostly because of security and performance and things like that. But it's very challenging to implement something like that in a debugger.
Mm-hmm. Have you ever played with JDB? Java debugger, the command line tool?
So I've been programming since the first beta of Java, and the first one that came on. And the first time I touched JDB was when I had to prepare a presentation about debugging on Docker and on Kubernetes about a year ago. That was the first time I ever launched JDB. Because, people assume that because I'm such an operating system geek and a Unix geek and everything, that I live in the command line and I do everything in VI and Emacs and everything. And I'm totally such the opposite of that. I love GUI, and I just, I can't stand working with GDB and JDB. And one of my colleagues is in his 20s, and he's a GDB nut. And I don't get that. I'm like, give me a good GUI and I'm there. I tore my teeth on Sinclair and stuff like that, where you didn't have an IDE. I grew up without code completion, without Stack Overflow, without internet. And, the fact that we have those things is such a blessing. And I don't get the young generation when they want to sort of suffer with those sort of tools. I'll never get that.
What I remember as I started with C and C++, and I think the debugger was GDB, right? GNU debugger.
Yeah.
I think this is for C++, right? Am I?
Yeah. I have a section about GDB, which G,
right?
For G. Yeah, GNU
okay.
debugger.
Yeah,
and
exactly.
I used it in the book for explaining RR, which is actually a pretty fantastic back-in-time debugger solution. Unfortunately, like lots of back-in-time solutions, time travel debugging, that's also correct. It's a tool that lets you debug after the fact. So those of you who aren't, system programmers might not have heard about RR, because it's very niche in the system area, but it's a fantastic tool. And the idea behind it is that you run the application with RR. Just you do RR and then run the native application.
Okay.
And something like Mozilla and everything. Mozilla, by the way, built that project. And it essentially records the execution
when they built
your
it.
application.
Is it new project or older?
No, it isn't new. It's not that old, but it's I think a few years back. And it records the execution of the application. And one of the things that it does, it literally saves the operations that you do. And then when you want to debug that, you take the output file that RR generated and launch it in GDB. And at that point, you can go back and forward in time and put a breakpoint in places where breakpoint didn't exist and inspect the variables in that place. So instead, imagine a VCR sort of, or a video player of the execution of your application, where you've got a time element that you can drag it. Okay, at this point in the execution of the project, I was here, and I want to place a breakpoint on that method, and we'll stop at all the times where that method was hit. During execution, you can go back and forward. And now you can't change anything, obviously, because the execution already happened. But you can inspect a bug, and you can inspect it from all directions. Go back in time, go forward in time, and understand what triggered the bug. And imagine to debug something complex like a memory leak or corruption, because corruption, a memory corruption starts at one point, but essentially manifests much, much later. So you need to start going back all the time to find that memory corruption. So it's corrupted here, then you go back, and then you look, oh, it's still corrupted here, and you go back, and so forth, until you reach the actual cause. And this is really hard with a regular debugger. With a regular debugger, you need to reproduce it, and then reproduce it again and again and again and again, constantly move the breakpoint further and further back. And sometimes you might run into a problem, because when you do that, sometimes you didn't reproduce it correctly, and you assume it was in the incorrect place. But with a tool like this, you can actually get a snapshot of a single execution and then trace it back. Now, this is a fantastic tool. It has lots of drawbacks. There's lots of time travel debugging solutions that I reviewed there. I mentioned one in the last show, the app map, I think. And it's a field that I think will revolutionize debugging at some point in the future, because it changes pretty much everything we think about when we look at debugging. I looked at some other tools like Replay and stuff like that for front-end development. Most of these tools are better with smaller things and with specific limited segments, but they give, and obviously there's the stream debugger in IntelliJ. That's also an example of that. These are fantastic tools. And I think that when we're debugging things like algorithms and things like that, and trying to understand, actually get a view of the execution, they're fantastic tools.
I take a look at your agenda of the book of the index and a table of contents, TOC. And so the next section would be rendering, which I can imagine lots of tips, show objects and mutual renderers and so forth. Then interesting one, debugging annotations, where you're pointing to the IntelliJ debugging annotations. Why is this relevant? So how they help us, the annotations?
So rendering and annotations are connected to one another. So rendering, essentially the watch area, lots of times people look at that area and assume it's kind of like fixed. They don't really spend too much time trying to understand what's going on there. Well, there's lots of complexities on how the IDE decides to print out the stuff that's in the watch area and how to display it. But effectively, at some point, if you have a custom object, it will just invoke toString, because it's got all sorts of logic to decide what to show. Eventually, everything fails. The failsafe is call toString. Now, there's lots of problems with that. One of the examples I give them there is the example of repository, which I assume Quarkus and similar solutions have a similar abstraction for JPA, where you can sort of have a crude repository where you can store JPA entities, load them, etc. The problem is the repository doesn't have a proper toString method. And I get why, because, what can you print about a repository? You can only print, this is a repository, and that's not really useful.
Should we always write toString methods? Now the question to you. Should every significant object has to have, a toString method just for the sake of debugging? Would be a best practice?
No. I think generally it's nice to have toString. I don't think we necessarily need to write them all the time. And renderers are one of the great examples where you don't need to write them all the time. Because, for example, I'll give you a counter example. Let's say I write a toString method and it's very inefficient. And then as part of my debugging, I log that object. Now, I'm essentially paying the price of the expensive toString method every time I print this object to the log. And that's pretty terrible. The solution is to have the functionality of the toString without paying the price of the toString in production. And renderers let us do that. We can define a renderer for a specific object type. So for instance, in the book and in my demos, I show how I take a JPA repository, which is Spring Boot's essentially crude repository element, and I essentially invoke the count method on it, which essentially does a count SQL statement on the database to count the number of entries in a table. Now, in production, I don't want to do that. Obviously, I don't want every time that I look at, or print an element, I don't want to do an SQL statement of count on a table. But while I'm debugging, I don't care. I can essentially do that. And that way I know exactly how many elements I have in the table, and I can see that instantly in the watch area. Even better, I show how when you expand, how to mark this node as an expandable node, kind of like an array. And then I show how you can expand the node and see all the JPA entries, all the entity objects within the table. So you literally see in the watch area the number of elements in that specific table. You press plus, and you actually see all the entries in the table as entities. And this is obviously very inefficient. There's a trick to make it more efficient by sort of clicking it to enable it. But this is a very powerful thing. Now, the thing is that you can do that, all of that, through the IDE menus. You can essentially define renderers which expose that sort of information. But one of the nice things is that you can do it using annotations. And these annotations are only read by the IDE. So in runtime, they have no overhead. But the nice thing is, as a library creator, as a provider of a module, you can essentially annotate your code to include these sort of hints. So if you're building a library that has such elements that are complex, you can essentially make them more debuggable to the end user. And that's pretty neat, in my opinion.
So the render, what we are talking about, is a feature of IntelliJ. So you can customize the views how it looks like, right?
It's a library that you can include. It's belongs to IntelliJ technically, but it has no dependencies. It has no runtime element. It's just annotations, and you just tag with a renderer annotation and give it essentially the strings that you would give in the IDE UI. And that way you can essentially get the same effect as a renderer and see without the cost of making a toString that isn't efficient and all sorts of other expensive costs of that time.
But the IDE will have to know about the annotation, right?
Yeah, it knows about the annotation, and IntelliJ knows about it, obviously.
Yeah, of course.
Third-party IDEs don't know about it, as far as I know, and renderers don't exist in VS Code in any form, not annotation or otherwise. It's still a very powerful tool when you want to essentially tie everything together to a simple UI. And, because viewing, when we're stepping over, the watch area is essentially the magic area. And when I step over in some projects, I constantly need to start expanding the object hierarchy to find that thing that I need. And that takes so much time. And it's distracting, and you're missing the point where it actually changes. And,
this is
Render solves that.
I'm working right now with JSON a lot, and this is if you have a JSON P, this is a hierarchy like a hash map of hash maps. So if I go to the IDE, I have to click on one, so I see the one key, then keep another one, clicking, and this is where I discovered logpoints, because I do the log point and then can say, okay, toString whatever I like, and I see the output there.
Yeah.
And
so this lets you see it right in the IDE.
But I have to say,
it's fantastic.
Instead of using log points, I think is also good a strategy to create beautiful logs, meaningful logs.
Yeah.
Because I do also some CLI stuff right now, command line interface with Java, and it's really nice to have nice logs. Without stack traces, now what's the tool is doing, and maybe you have debug level or not, or info level, and I think writing logs is as complex, I would say, as writing good Java doc, right? So for me, what I really hate in projects where every time
more so.
Yeah, enter method and exit method, or even worse, the question: can we log in an interceptor? Saying what is the added value of such a thing? We have debug, I see the stack trace already. Why I need another interceptor logging the same? So I'm interesting that this is on my side, because this is
I have a talk about that in a video as well, about logging best practices. So, and there's also about that in the book about logging. So I'm a big advocate for logging. I'm against printing, because printing is essentially ephemeral. It's something that you do for debugging right now, and then you accidentally forget it and commit it into the code. So that's pretty bad. Normally you'd want to use tracepoints instead of printing, unless it's front end, which is a special case. But for logging is a permanent thing. It's a permanent record sort of situation, and that's really important. The thing about logging that there's lots of nuances, but one of the big things is the cost. I've worked with lots of companies that use essentially logging for them is the only way they can actually trace something in production. And, it's sort of precognitive debugging. You sort of need to know what you will debug ahead of time, planned the log for that and sort of designed that debugging experience for later on. And the thing is that you pay for that right now, because the cost of log ingestion, the collecting of the logs and keeping them indexed and everything, and even without egress and those costs, is tremendous.
It is. Shai, for instance, if you have in serverless project with Java, logging is a major cost factor, if not the largest. So this is widely underestimated, actually. Mm-hmm.
Yeah, we estimated it was 30% of the total cloud costs are logging costs. And that's a huge, huge expense. And lots of times these logs are redundant, stuff that the developer just added carelessly without actually giving it any thought. And it's very, I see companies spend so much time on things like code formatting. They all have a every company I went to had a code formatting guideline and standard, and very few had a logging standard. And that's insane, because I'm making a pull request for a project, and in that pull request, I have some logging or have no logging or anything. The person reviewing my pull request has no sort of standard to align with. So one reviewer will say you have too many logs, you might be wasting time, your log level is wrong. And another one will say, you don't have enough logs, and overlog on the other direction. And there's no uniformity there. And because of that, the logs are also unreadable and unpleasant to read and expensive, as we said. So there needs to be a standard. I actually have that video there about that standard. And it sort of needs to be per company. And if you have a coding standards document, you should have a logging standards document. There's no question there.
What also important is, from my perspective, is to map exception types to log levels. Because this was a mess, so there's like developers that choose randomly the log levels with various kinds of exceptions. So I would say, the system exception should go to this log level, and more like warnings, like violation errors, more like warning level. This is also important in my eyes. This thing, and the last one, if you log, I would like to see how you find the information. Because all the log aggregators, they need, you have to, at the end of the day, you have to write a regex or something to find, the information there. And I think it would be good practice at the beginning, to write, to have a rough idea about a pattern, which you can easily find later, for instance. And this would assume that I would actually write some tests against log files.
Both of those are in my talk, by the way.
I never saw your talk, but very good. So if someone invites me to a conference, I can point to you. So Shai also can speak. You have the same, the same ideas. We will put your talk to the show notes. So I will also have to watch your talk. You are dangerous, guest. I already bought your book. I will have to watch your talks, and see what we have in common. I will skip the process section because this time we are very organized, and I would like, to complete your book. Under 5 hours. This is my personal goal, and we can talk. But unit testing, maybe we come later to testing. But there's an interesting section about external tools, and what you don't have, I think, you don't have btrace, right? Do you have btrace?
No.
You see,
I didn't talk about btrace there. I intended to get there. But after strace and dtrace and everything, I kind of decided, there's a point where you need to make a cut. And unfortunately, btrace got cut.
How I know it? Because dtrace, of course, this will know the Solaris, like I would say, killer tool, right? I think no one had just Solaris. It was like a killer use case.
Still, it's available on Mac now. It's available on Windows. There's a version for Linux, but it's not by default. You need to sort of hack to get that. That's mostly because of licensing. On Mac, it's disabled by default. So you need to sort of enable it, disable their security stuff. It's not as nice as it used to be.
And what it is like AOP on operating system level, right? So it's like whatever happens internally,
it's fantastic.
You can. And btrace, I remember why I know it, because there was the java.net website. And they announced that For me it was like incredible. So okay, this is a btrace, like dtrace for Java, and this was called btrace. And I saw dtrace. I remember btrace. And I said, okay, but there is nothing about at least something I can criticize on your book. There is no btrace. You see?
That is
So
correct. I
you
really
get only
wanted
4.9 stars, not 5, because of this. But okay.
So there's JStack and all of that. All the
you are explaining
tools.
dtrace, strace, JMX term, then JStack, JMap, JInfo, and JXMap, and GUI debuggers, and Wireshark, which is incredible. Also had to use that once. And now about testing, maybe. Because it is also interested about your opinion, because also a section about testing there. And what I'm doing, I'm spending my time mostly either in front-end like CLI tools with Java, or back-end like Quarkus, like Java E microprofile tools. And how I test, actually, I started several polls on Twitter just to see what other people are doing. And for instance, unit test, I discovered myself doing something strange. So I start to write production code in unit test. And if it works, sometimes I leave it, for small CLI tool. It is just a unit test. But if it is more valuable, I migrate or move the code out to a production class, then reference the class from the unit test, and then write asserts. And this works, for me, it is very fast. I don't know whether it is the correct way to do it, but it works well. And this would be, I called it yesterday, ultra test driven, because I have just a unit test without the production class. And then this works for me. But this is like a small hack. That doesn't mean anything. But what's more interesting is if I'm on the back end, I never start with unit tests. I write black box tests from the outside, because I'm absolutely not interested, to testing getters, setters, enums, or exceptions to increase the code coverage. What I would really like to have is at the very beginning, to call the system from outside and see whether, the entire stack is working. So this is my approach. Is it also would be your advice or not? This is interesting.
So I never really got into TDD. I tried lots of times, and I can't think in that way usually. It works great when you know the problem in advance. So if I do exercises and things like that,
but we never know, right?
So I think lots of people in academia like TDD because they know the constraints of the environment, and so taking the tests and working with that is easy. It's also popular if you have an existing system. Then you write the tests for the existing system and then create the new system based on the tests. And that sort of provides a migration area. But starting with tests for Java isn't as useful. It's useful for the languages that are loose, where the tests sort of work instead of a compiler, and verify things like method signatures are correct and those sorts of things. About one of the problems I have with TDD and the core conceptual problems is that it overly emphasizes, this sort of goes towards your argument there, it overly emphasizes unit testing instead of integration testing, which is far more important than unit testing. I mean, I love unit testing because unit testing runs quickly and I can sort of verify things. And when you want to write, there's a process for debugging, which is in the second chapter. I talk about it a bit. It's that in order to solve a bug, you need to first create a unit test, ideally unit test, to reproduce the bug and only then solve it. So unit tests are really, really good for that, to stop a regression from happening over again. They're good for tools like git bisect, which is fantastic. So having a unit test, wonderful. But it doesn't really test deeply. And when I want to get coverage metrics, I ignore unit tests because I think coverage in unit tests is misleading. For me, coverage only matters for integration tests because quality without the integration of all the pieces isn't quality. It's sort of expectation matching. And I'm not here to build tests. I'm here to build a quality product. And unit tests sort of look nice. They don't actually deliver the type of quality that the application needs. So I can't build a test, usually I can't fathom it before I have something running. So I don't do that, but your approach sounds good. If you can do that, then kudos to you.
Yeah, we have to
I'm
do this.
sort of code first.
If we don't do this, what developers will do, they will start, Postman or curl and try to automate there, and this get lost because it is not checked in usually. So either and what I always doing for years. Actually, last week there was an internal talk, and I found my old J2E code. It was like 10 or 15 years old, and it was the same. So what I'm basically doing, I have two projects. One is called, let's say, debugging module, and the other one would be debugging-st, stands for system tests, and they're like black box tests. And the other module calls the first one. And I did it, at the microservice, as the microservice were popular back then, because only there you can assure that the second module has no dependence on the first one. So if there is no deserialization going on, JSON, whatever, it has to work because it's like decoupling. This is the real world. And this is my master. So we're starting with this. So this should be, this drives the other one. And if something goes wrong, we re-execute the system test and see what happens. So it is not very popular, I would say, because what most people are doing, they're writing system tests in the same module. And the problem with that is, of course, you're always in the right version, right? So what I can do with two modules, I can actually go back a view versions and see whether, the old version of system test works against the newest microservice, which is impossible in one module. So I would say this is, the cost of a microservice. If you would like to have microservices, you have to, to test from outside. And your remark regarding code coverage, also absolutely my opinion. So we have to, be careful what we are talking, or not careful. It's interesting that you see this also similarly. And what we are doing, we try to run the server with code coverage, which is simple. You can you can just use the how it's called from Eclipse, the project, the code coverage project. What is called? There's like an agent. There's an agent which you have. There's an agent from this is Eclipse. Jacaco, exactly. Jacaco. This is Java code coverage. Jacaco. This is exactly the project. So we launch Quarkus or Tomcat, whatever, with the Jacaco, and then if you launch the system test, you get code coverage of the project. And the cool story is, you can then open NetBeans or IntelliJ or whatever, and you will see in source code actually, because the file Jacaco exec I think can be read by the IDE. And you can see what was not tested. Now the interesting part is, right, if you call the system from outside and there are some leftovers with zero code coverage, is mostly forgotten code. So what we do, we're misusing code coverage to identify that code, for instance. So this is a hack. And another thing, I don't know, this was... I actually last time you mentioned something with clusters, I think, and I wanted to say it, but it was too late. So there was a migration project, and client asked us how about the migration strategy, how to migrate. And I said, okay, these are old projects. I'm pretty sure not everything is used in production right now, so we should migrate whatever is used, and what is not used, don't migrate it. So how to find it out? So what we did, we started one node of the application server in code coverage mode in production, and we left it for 3 months or whatever. And then we saw what was actually used. So through the code coverage, we saw, okay, this is parts which were never used. And this was actually my argument that we can actually move only parts of it. So this was also a nice hack. I wanted to mention this last time. I remember
that's an interesting concept. I like that.
Yeah, but it only worked in cluster because you have to be careful with the memory. So I thought actually it will break, but it worked. It was Whitefly or WebLogic back then, but it works surprisingly well. Okay, cool. So interesting part. Nice hack. The next one was stress tests. So if something works or doesn't work on backend, it cannot be tested by unit tests. We launched JMeter back then. Now it's popular again. So it was quiet around JMeter, and now it is like a revival. And by the way, did you know that who wrote JMeter? You know the guy?
No, I don't.
The same guy who created Kubernetes.
Really?
Yes. Yeah, he works for Microsoft. I think it's really interesting. This is one of the Kubernetes committers. And okay, JMeter, a Swing app, which launched the test. I actually don't care about the results. What I would like to do is to generate massive load and see what the server does. And I also try, now it's called fault injection or chaos monkey. And back then there was no name for it. What we did, we misconfigured the application server on purpose, and usually thread pools. We, for instance, JDBC connection pool with not too many not sufficient connections, for instance, like let's say 2 connections, we had 30 threads, and see what the application server is doing. So will we get timeout, or is something locked in the log files? Because if it happens in production, we know what to do, for instance. And this was completely ignored. So in large companies, stress tests, system tests, completely ignored. And at least in Europe, everyone is after code coverage in unit tests, which is pointless. Because back to your repository example, let's say I have a CRUD application, and if it is not unit testable because a CRUD application has 0 complexity. What I can do, I can just say whether I can check whether the database is working. But what's more interesting is from outside with system tests, where they know the entire serialization, deserialization until the database. What I see in project instead, JAX-OS completely mock out. I got questions, can we mock out the entity manager? It's like, yeah, but if you mock out the entity manager, that there is nothing left. I mean, then you will test your own mock, right? So this is, interesting. So now I have someone I can talk about testing. Usually, if I mention something in project, there's a lot of trouble with that because of test driven mostly. Your book is crazy. So you covered observability and monitoring. And what I want to ask you, why you started with Kubernetes? I mean, there's a lot of stuff. Why are you also describing Kubernetes in the book as an example of distributed debugging, or?
Technically, I could have made it more generic and talk about observability on orchestration in general. But debugging Kubernetes has special capabilities like kubectl debug. And the concept of ephemeral containers is essential when you want to sort of troubleshoot at the scale of Kubernetes. Now, it's, I guess, if you're using Lambda and everything, it's kind of, you're getting away from that a bit. But when you're dealing with Kubernetes, whether managed or unmanaged, you still need to understand what you can and can't do. And I essentially structured the book in sort of the stuff that you do in the client side, and that includes the debugging tools that you can use like strace and stuff like that. And then you can take some of these techniques and move them into Kubernetes. So I can run strace on a Kubernetes container in production. Ideally not in production though. But the thing is that if I do that, I can create a problem if I just do an exec on a Kubernetes instance and open a shell there. It's not like the days of old where we could just log into a server and start doing whatever we want. So I needed to explain those ideas, and Kubernetes is the de facto standard now. So I chose to go with that. Because the book is targeted at developers and not at DevOps, I had to sort of explain Kubernetes and where it comes from. Because otherwise I'd kind of lose a significant amount of the audience at that point. So that's right. Why I went there to some degree.
As an example, it's okay, because this was a jump for me. It's okay, why Kubernetes now? But maybe now forget about the book, but you also work on startups. And what I wonder, so my observation is, just opinion, if you would start a startup, something, right? So let's say, I don't know what, sell t-shirts. So, and we go to the cloud. I would say Kubernetes would be the last thing I would use. It is absolutely pointless. Because...
if you look at the book, you'll notice I include there in a footnote, when I mention the need for Kubernetes, I provide a link to doyouneedkubernetes.com. And if you go to that website, it's a very sophisticated algorithm. It just says no. And because we don't need Kubernetes. Big companies, they don't need the scale. Lots of times people sell Kubernetes over the scale. That's unless you're Google or Amazon scale, you don't need that. The value of Kubernetes for larger companies is mostly in organization. in the fact that the relation between the different services is really well defined. So an ops person can actually manage everything using existing tools. And there's lots of the third-party support for all sorts of capabilities in a managed environment, and also on-prem and everything is completely is very flexible and very well defined. So I get where organizations need that, but for scale, you probably don't need Kubernetes and probably don't need microservices either.
No, and my observation is large organizations, architects are assuming that Kubernetes is cloud native, is like standards, and without Kubernetes is not portable or not even possible to go to the cloud. And for me, Kubernetes is perfect for on-premise. I mean, what you can do now, if you would like to have your private cloud, you have to pick something like Kubernetes. And my Mesos is almost no more available, so Kubernetes is the de facto standard, I would say. I would use an Orantia or OpenShift, for instance, and go with it. But in the cloud, if you deploy Kubernetes, you're deploying a cloud inside a cloud. So you have the double complexity and you have managed everything twice. So, and if I start, to explain, you look on Azure, we have Azure Container Instance with one node. You
do have the advantage of some flexibility. So you could potentially move some loads to on-premise, but the moment you standardize Kubernetes in the cloud, you give yourself, I know, vendor neutral is kind of got lost with the cloud. And we're kind of all deeply in vendor.
But the problem with Kubernetes, Shai, is we have the Helm charts and all that stuff. You have to build in order to deploy. Hundreds of lines of YAML. But if you go, let's go the completely proprietary way and go to Azure Container Instances. So there's maybe like 30 lines of JSON to deploy a Docker container. The same is true on Fargate, on AWS, or Lightsail on AppRunner. So I would say switching costs are relevant. The question is how much time it take, to migrate from AWS, let's say, to Azure, regardless what you are using. I think what is more important that we use a kind of container if you would like to run in a container. And if you run in a function, it also doesn't matter because my Quarkus runs happily as Azure function or AWS Lambda. I don't care. So it's exactly the same, bytecode. So there is no difference. So I would say I just wanted to hear, your opinion. But
I got burned a bit by past solutions in the past and the difficulty of debugging them and troubleshooting them. On the other hand, Kubernetes is so ridiculously complex that even if I have access to everything, it's still really hard to debug some of the ops-related problems there and all the interconnect elements that exist there. So I'm not a huge fan of going with Kubernetes, and I think a lot of the excitement around it is really resume-driven design, where people kind of pick it based on that. On the other hand, I'm still, when I deploy my personal projects, I just open a VPS. I then go to Lambda. It's like $5. You can get something better than Lambda as far as I'm concerned. Yeah. And without the risk. I'm willing to pay $5 instead of free for Amazon because I know that the free on Amazon might suddenly become $1,000 overnight. Yeah. But the $5 I pay for VPS will stay $5. It might crash, but it will stay $5. So I'm absolutely with you. Very much for control.
I would say if you can, I will always deploy on premise, my private cloud, right? So I have my own server, not even VPS. I have my own machine, which with all my stuff. So it is even better. But if it's not possible for various reasons, and you have to go to public clouds, then just use the cloud, not fiddle with something what you had on premise and try to replicate it in the cloud because it's get more and more expensive. Also on Kubernetes, because it comes with additional costs, like the control plane costs. What I see is what companies tend to do is to deploy large clusters of Kubernetes, which are isolated internally, which is really harder to operate. So, and if you have proprietary solutions, they are smaller. So it is easier to isolate. So I just wanted, to hear your opinion as well, if I have it here. The last time, maybe, of our series. Anything we forgot to add regarding your book?
Well, there's a lot more there. You know, we just got to chapter 6, I think, out of 14. So, yeah. But generally, yeah, there's lots of stuff there. I think the most important portion that's maybe subtle is the theory that we kind of skipped. I mean, ignoring the stuff later on, we kind of skipped over the theory. Now, I made theory as the second chapter instead of the first chapter, because I think, you know, starting with theory is sometimes a bit difficult for people.
Okay,
you know, I like
that's the deal.
having something sweet.
With a little break, maybe, you know, summer or autumn, I invite you and we will talk about theory. We have to, you know, to synchronize ourselves. So maybe I will read your book then, and until then completely, and then you know, ask.
Send me notes to fix for the second edition. I already know, so it's a test for you. I know the mistakes that are there in the version that's out, so let's see if you track them.
Okay, thank you. Where people can find you and buy your books and watch your talks?
Debugagent.com and youtube.com @debugagent. Has all the talks, including the one about the logging best practices, and lots of other talks like that. Lots of videos in general. I'm on Mastodon as Debugagent and Twitter as Debugagent, and I'm on LinkedIn and everywhere. So find me wherever social networks.
And even on our Airhacks chat Discord as well, right? Yeah, we already chat.
Yeah, although I don't log into Discord as much, you know, it's too
from time to
verbose for me.
time. Not our Discord. It's actually there's from time to time a nice message, and it is really nice to meet people because you can send them direct messages, you know. So it is a nice quiet medium, I would say. So okay, great. Enjoy your winter and the nice temperatures, and yeah, hear you next time about with the theory.
Yeah. So speak to you soon, hopefully.